Problem 332, we should estimate the minimum number of subintervals needed to approximate the integral with an error magnitude of less than 1/10,000th using the trapezoidal rule. This is our integral of the function is 1 over x minus 1 squared dx between 4 and 3. So we will use this error the trapezoidal rule. Now the b minus a, that's the 4 and 3 of our bounds of the integral. M is the max of the second derivative, and 12 over n squared, n being the number of trapezoids that we will need to find. So first we'll plug everything in. The error, we want it to be less than 1/10,000th. And the 4 and the 3 go in there in their respective places. So we have 1/10,000th. We simplify it a little further down to right there, where we really need to know what the max of the second derivative is. So we come back up here to the function, and we take the first derivative and then the second, which the graph looks like that in the bottom right corner. And as you can see, there will be no maximum because it just kind of goes up to infinity. But not to worry, we will have a maximum because we're just trying to find between 4 and 3. So it will from the look of this graph, it will be at 3, which the max will be 6 over 2 to the 4th, which is 0.375. So then we can plug that back into our n, or for our m, and we can simplify it down to the square root of 312.5, which we'll get n has to be greater than 17.5 trapezoids or so, which you can't have half a trapezoid because n is an integer. We need 18 will be the minimum number of subintervals so that we can approximate that integral with an error magnitude of less than 1/10,000th.